Yeah, we discussed, sorry, some issue with my screen. Yeah, we discussed about environment variables. Sorry, some issue was with there with my screen from my side. We discussed about environment variables and we discussed about loops. We started learning about loops and etc. That was what actually we have done yesterday. So go back to the loops once again, just to explain. So this is a normal loop. There are only two loops in Go language. In fact, there is only one loop which is called for loop. There are variations of for loops, for and then the other one is called for range loop. But basically, Go has got only for loop. Go doesn't have a while loop, do while loop, or something like a loop in um, Rust. Nothing. All these things are not there in Go. Go has only one loop that's called for loop. You can use go to statements to write loops, but yeah, go to statement is not a loop, it's a jump statements, conditional jump statement. Conditionally, you can write like a loop, but go to is not a loop, but you can use go to as a loop as well. But it's basically a jump statement. Fine, we'll see that later on. So, this is the loop, this is another loop, and here we use continue keyword. Here use loop like a for loop like a while loop. Just put a condition over here. Here we didn't put condition inside the loop, but we wrote the condition elsewhere. So we used break keyword. If I equal to 50, we used break keyword. And here we didn't use the post condition, the increment or decrement, whatever it is. Uh, but just we used I equal to 50, then break it. Uh, uh, we didn't use neither the condition nor the post condition. Condition is used here and then post condition is used here. And we also write a loop, unconditional loop. Basically, this loop doesn't have any condition, uh, doesn't initialize a value by default, doesn't have any condition, then doesn't have any post condition. This loop iterates just like that, but everything we put inside the body of the loop. This is the scope actually. Loop starts here, loop ends here. This is the body of the loop. Right. These are the things that we have done. Let's go to the another example. Yeah. So uh, loops are not confined only to in fact not only to one variable that you are already aware of that. For example, okay, for loop can have multiple variables. For in fact, actually, whatever we are writing here, it's a block, it's a scope or a block. So here you can do normally whatever you can do inside a function, right? Fine. Let's go and then create multiple variables. Let's say I want to create two variables. I can initialize two variables. So I and j, which has got uh, 1 and 10. I want to iterate loop until I not equal to j. Okay, until the value of I is not equal to j, I would like to iterate. You know, I not equal to j, I would like to iterate. And the third one is I comma j. I want to assign I plus 1 comma j minus 1. You see that two variables I and j, 1 and 10, uh, I not equal to j until this is true, the loop iterates, this is the condition, and then I and j, the value of I is I plus 1, value of j is j minus 1. That means at some point of time I and j become I and j are equal, then the loop breaks. Just not doing anything, just printing the values I comma j. So I think something went wrong. I did what what happened I is until I less than or equal to j. Yeah. So until I less than or equal to j. So I you see that the fact is actually I and j are not equal. The reason is the moment I becomes 6, j becomes 5, so they would never become equal. That's what I did something wrong. So until I is less than or equal to j, okay, the loop has to iterate. Nothing, just for you that yeah, you can also initialize more than one variable inside the loop. Fine. This is one example working with. So multiple loops. There is something called multiple loops, multiple nested loops. Nested loops means there is a loop, maybe I equal to 1, I less than or equal to 10, I plus plus. There is another loop for j equal to maybe 2, j equal to 5, j less than or equal to 10, j plus plus. I have two loops. Okay, so what I would like to do is if I equal to j, so I print the value of I, print line value of I, and then j is j. If I equal to j, both of them are equal. If I and j are equal, I equal to j. Okay, I would like to break. So whenever you see the break statement in a loop, break breaks that only the inner loop. So okay, let me print line nested loops. So when you look at the nested loops, what happened? I become 1, j becomes 6, and then okay, from here I and j both of them are 5. Okay, I and j both of them are 5. When both of them are 5, what I did, I break. So you see that because I break the inner loop, j value did not increment from here, then it goes back, I has become 6 and starts from 5 6. Well, for all the value of j would be 5 6 7 8 9 10, but for this condition j would not be incremented. The reason is because of this condition. But the catch here is break breaks only the inner loop, but not the outer loop by default. So how can you break the outer loop? Let's say I can do, like, for example, if your requirement is I would like to break the outer loop as well, I can say something like done false. For example, I equal to j, then I say done equal to true, and then if done, I say break. What this does is what this does is when I equal to j, I say done is true, it break this loop. The moment this loop is, you put break to the loop, it goes back to the I. Since the value of done is true, it breaks this loop as well. This is how generally we write as well. Generally we could write like this. Okay. So instead of writing like this, you can write like that. Then the output is not what you really expect. Because I and j are equal, it breaks this loop as well as the other loop, so that unlike earlier, the loop would not be iterated for j. For I, it would not stop because it breaks both the loops. So instead of doing this, you can use another pattern with the, it's not a pattern, but you can use another way of doing this. What you can do is, you can use the label way of mechanism. I can put a label over here. The label name is out. Label name could be of anything. Okay. The label name is out over here. The label name is out. It's a just label. You can give any name. Basically, you can give any name. Any valid identifier could be any way label. Okay. You cannot give an invalid identifier like starts with numbers and all, but or with a special characters it doesn't accept. You can give a normal variable name, and then you can say go to out, breakout. Sorry, breakout. So what happened when there is a break? Here, break not only breaks the inner loop but breaks to the label, breaks until the label, breaks to the label. It breaks to the label. Label is here, so label is outside of outer loop, so it breaks out of breakout. You can give any name as well. As like if you put a, it can be a. It's not necessarily to be out. It's just a label name. So the break with a label pattern take you out of that particular loop. This is where now what happened if you run the application, whatever with the done you are doing, the same thing works over here. The done pattern work only for two loops. What if you want to get it work for three loops? Then you need to have one more done, four loops, some other variable. You need three variables because break breaks only one loop. More than one loop, if you want to use break, you cannot directly use break. Rather, you have to use something like this outer label or something. You have to use. That's how you have to use. Okay, which is called uh, out of this stuff like that. This is something like a break out loop. Okay, this is something like breakout. It's directly from the breakout. Okay, this is something that uh, uh, yeah, for your understanding, this is one way that you can do. Okay, any questions you have, please do ask. Otherwise, let's move further. Okay. I don't think for loops and all, I don't have much questions because these are the basics, but I'm trying to explain what Go does, especially. I'm not explaining you the loops. Loops, you are already well aware of that. You have been doing programming for years, so definitely you know about loops. I'm just explaining what and where Go is different in terms of loops with respect to, akin to other programming languages. Fine. This is what that. Fine. Let's go to the next one. We can also have a look at, so these are two loops. Okay, fine. The next one is for range loop. Let's go to for range loop. This requires more information. I tell you why it is. Let's say I put the word called hello world, str2 equal to somewhere we wrote somewhere in variables, Chinese word somewhere we wrote. We have two variables str1 and str2. What is a string? String is collection of what? String is collection of bytes. String is not collection of characters. Remember that. Never ever think that string is collection of characters. String is not collection of characters. String is collection of bytes. Okay. Just type print str1 and then str2. Just printing. Now I want to access character by character. In fact, it is byte by byte. So I use a loop for I equal to 0. There is a built-in function. Okay, I less than length is a built-in function str1. Length is a built-in function. We would like to iterate until the less than length of str1 I plus plus. And then what you can do, you can say print str1 of I. That means you are accessing each and every character, but it gives byte. If you run it, it gives bytes. If you put it, you understand it give byte. 72 is for H, 101 is for small lowercase e, etc. LL, 108, 108 and all. So how do you convert it? You put as string. Convert that particular byte to string. A byte can be converted string. A byte array can be converted to string. We will discuss about it. A string also can be converted to bytes. You know that casting actually, it's not conversion. Casting cannot be done between different variables. There are some limitations, there are some rules to cast. We already discussed about what is casting, what is conversion, and then what is also type assertion. Fine. So this for loop, okay, what what happens if I do the same? Okay, if you look at it, this is, sorry, this got to be the answer because you put a space over here. You can see this. Okay, let me remove space. Let it be. Just put space. This is the answer. What happened if I do the same thing with str2? So this particular loop, what happened is this particular loop, we are doing I0 and I less than length of str2. The length of a string is always the number of bytes inside the string. That's what the length is. Here actually these two characters holds 6 bytes because these are Chinese characters. These are all normal ASCII values. So this works for normal English characters, but this doesn't work for these kind of characters. Okay, the loop doesn't work. Doesn't work means the way how our intention, according to our intention, it doesn't work. It works according to how it works. So you see this, the moment the characters are going beyond the ASCII values, because each character does not hold one byte, more than one byte, you know, the characters are distorted or something, you don't find the exact characters because we are accessing byte by byte. We are not accessing character by character, we are accessing byte by byte. Okay, this is something. So I always say that when you are processing strings are different. When it's a kind of a stream of a string, or you're processing strings, it is okay to use normal loop, but you are printing strings or you are using strings for the string manipulation or character manipulation and all, always do not use this particular loop, because as long as the characters are ASCII characters, there is no problem. The moment the characters become Unicode characters, that means, of course, ASCII characters are also part of Unicode character sequence. But what I mean to say is, when the moment each character holds more than one byte, there is a problem. This can be solved. One way this can be solved, that you can convert the characters to a string to rune. We will see later on. A string can be converted to rune. Rune array. You know that rune. Okay. A string can be converted to rune array. A string can be converted to byte. In fact, byte array. We will discuss about arrays. You know that what is byte, what is byte, and what is rune.
Byte is just integer only, right?
Byte
Smaller than
is
that.
uint 8. Uint 8. Okay, byte is uint 8. Rune is int 32. That is the difference. Okay, so byte is nothing but uint 8. If you even look at it, a byte, you can see that. So byte is an alias for uint 8 and is equivalent to uint 8 in all ways. It is used by convention just to distinguish byte values from uint 8 unsigned integer values. We are just using for convention basically. Byte is nothing but uint 8. The values of uint 8 are given there in the byte, that's all. Rune is nothing but int 32. Okay, so that is the difference. Fine. I hope you got the clarity. What the byte and rune. Rune already you know, but byte is also nothing but uint 8. So these two
Vijay,
are, yeah.
what's the shortcut to go to the find out the documentation? Is it go to
I
definition?
just typed. I used uh, a command button on my MacBook. It could be Windows button on your
Okay,
Alt button,
control,
either Alt or Windows with a click.
control maybe.
Yeah. Which one is it? Windows
Okay,
or Alt? Just press that Windows button and click on that. It goes to a package called builtin.go. This is the built-in package.
thanks.
Yeah. Uh, so when 1 minute. Yeah. Fine. This is what actually the difference. So generally, what happened? We shouldn't use. I'm not saying we shouldn't use. You can use, but when you have to convert it to rune and then access runes, there is a way to do that. But generally, we don't do that. Regularly, we don't do that. This is quite uh, comparatively. You can't do straight away approach for this. So there is one loop especially to work with collections. There is a loop to work with collections. Collections means strings, arrays, slices, maps, channels. These are the basic collections. It could be a string, it could be an array, okay. It could be a slice, map, or channel. Okay, there is one loop. Basically, range is the loop. For range loop, the behavior of the it's not the behavior, the return values of range loop differs based on va- various things. Based on what on which collection on what collection on what type it is being used. I will explain that. You will also come to know. So, how do you use range loop? Oh, nothing to do this. How do you use range loop? For particularly range loop on uh, range loop on strings, arrays, or slices. These three strings, arrays, or slices. Range loop returns two things. The first one is called the index. The second one is called the value. The range loop returns two things, index and value. If you are using range loop on a map, the first one is key and the second one is value. If you are using range loop on a channel, it doesn't return two values, rather it returns only one value. So there is little different the way how you gonna use a range loop. Okay. So a range of str2. This is the range loop. Okay. Range loop is gonna give you two values, two things. One is called the index, other one is called value. Index means which index in when it is iterating, what is the index, while during iteration is what the index is. We will use index for now just to see that how the bytes are merged and then form a character. For that, right now we will use the index. So I use print line index. I say I, which is called index, and then the value is always a rune. In range loop on strings, the value is rune. I got to convert it to string. So I'm using range loop for range. Okay, range is a keyword, for is a keyword. You can see this in this color, rose color. These are all keywords. It returns two things, index and then value. Remember that, index and value. Index talks about what index during each and every iteration. The value talks about what is the value at that particular index inside this collection for this collection. So let me put the print line over here because it is taking from the continuing from the previous loop. So this is where you see that zeroth index is a Chinese character. That means it took three characters, 0, 1, 2, and then form one character. After that, 3, 4, 5, it took three characters and then form 3 bytes and form one character. 6 onwards, these are all normal ASCII characters, so each byte has got each character. So that 6, 7, 8, 9 up to 17, the same thing. But the first two characters, you see that. So the range loop can understand that what exactly the character is. Range loop can understand that. Range loop is capable of understanding that. Okay, this is what the range loop is. Recently, with the advent of the new versions of Go. Okay, the range loop can also work on range of values. This is a new one from version 1.22 onwards. This was not possible before version 1.22, but you can range from 1 to 100. It is 0 to 100. In fact, it's 0 to 100. You can write a loop like this. Instead of this, for I equal to 0, I less than 100, I plus plus, you can write like this. Generally, you don't see people use this because this relatively new version from new version of Go, so you don't see people really use this, but you can use this. What I mean to say, you can use this. That's all. You can do this. So it starts from 0 to 9, less than 100, less than 10 over here. This you can use. Wherever you find you would like to iterate, you can do that. You can do this. Okay, this is also a range loop, range from 0 to some number, the value. You're creating a variable over here. So the variable is created and starts from 1. So this is index and value. You are iterating from an index and value. This is how it comes as well. For example, I don't want index. Let's say I want to print the loop for, uh, I want to print the loop for str2, str1. str1. I don't want index. Okay, if you don't want one variable, what you can use in Go language, the function is going to return a variable, but you don't want a variable. It's not a function, however. There is a concept called blank identifier. Blank identifier can be used. So basically, blank identifier means I create a function, let's say calculate, I pass two values, it's gonna return add and subtract, for example. Otherwise, I create a function, okay, I create a function called rectangle, I pass L and B, float 32. This is going to return area L into B, comma perimeter 2 into L plus B. So this function, I told you that functions in Go can return more than one return value. This function rect is going to return two values. Just to explain blank identifier, I am telling this. There is nothing to do with loops here. Okay, because here I have to explain about the blank identifier, so I am just explaining what the blank identifier is. Okay, so I want to get the area and then perimeter. Rect of, maybe I give some value to the rect. This function is going to give area and perimeter. I can print fmt area a1 and then perimeter P1. Okay, you got area A1 and then perimeter P1 here. Fine. This is well and good. I call this function once again. I give A2 and then P2, maybe different values. I don't want perimeters. Now I don't want to calculate perimeter. I just want area. So here I can use something called blank identifier. If the function is returning more than one value, you don't want the other value. Okay. If the function is returning more than one value, you don't want the other value. You can use a concept called blank identifier. Okay. This got to be the blank identifier. This is called blank identifier. Blank identifier is very regularly used in Golang for many purposes. Many purpose means the purpose is same, but in many use cases we use for functions, for loops, for range loop, for using packages. You want to import a package, but you're not going to use the package like that. You can use blank identifier in many areas, but the purpose is same. You want the purpose is similar to this. Let's say I don't want to you I want to use the perimeter but not the area. You can use blank identifier over here. This is called blank identifier. Okay, this is called blank identifier. I hope you understand what the blank identifier is. Blank identifier means if the function or any construct is going to return two values, you don't want to you don't want the other value, second value, you can use a blank identifier. Similarly, when you are using a range loop, okay, for this particular str1, here I just would like to see that what the index is, how the index is jumping, how the index is merging multiple bytes and then showing. Okay, okay. But really I don't want to, in the str1, I don't want that because I know that str1 is going to iterate each and every byte. So I have nothing to do with this. I I don't want it actually. Then you can remove blank identifier. You can put a I. You can remove I and put a blank identifier. This is the blank identifier. Range is returning two values. You don't want the first value. You can use just put a blank identifier. For example, you want first value. For example, you want first value, but you don't want second value. You can put a blank identifier over here. In fact, for range loop, if only for range loop, not for function. A function, if you don't want the second value, you can't do like this. Still, you have to put this because function is returning two values. You need to substitute the second value with a blank identifier if you don't want the second or first return value, whatever you want. Here, but for range loop, there is a facility that you can remove this. You can still do this. Okay. However, this is nothing but this. Both of them are equal. Okay, you can guess. Many people do like this because for the clarity. But recently, people who have been working with Golang for so long, they do this. I do this, but later on, I think they have added like this. So the first value only you are doing, you can do that. Okay, I is just a variable. Fine. So this is called the blank identifier. I hope you understand what do I mean by the blank identifier. Okay, you got hello world. Here I want to know the bytes, so I used I. Uh, so how it merges 3 bytes in and then form a character. But second one, I know that there is nothing like that. All of them are ASCII characters. I just print it for your understanding purpose. And this is the function. How do you create a function? A function that gonna return more than one. In fact, functions can also give the named parameters, named return types. You can also give like this as well. A and B are two parameters, but return arguments. The return values they are. You can also give a equal to L and B, a comma P. You can also give like this A and B, L and B, and the second value is guess this, and then you can return a comma P. Still, you can do that. These are all named return types. This is better. The reason is it gives some clarity looking at the function. If you just give float 32 and float 32, you can't understand what float 32 is going to return. Okay. But if you give names, even if you give even properly area and then perimeter, this gives some clarity that okay, area is it's gonna give the first return type is going to give the area, second return type is going to give the perimeter. Some people write very verbose way. Some people write single letter just for area and something like this. It depends on what exactly you do. But I don't know what the spelling depends on actually. It depends on uh, how we do and all. But we can give that depends on you know I think this one is the correct spelling. It depends on how you do. It's a named return types. Here it's not a named return type, the previous one. But this is what the blank identifier is. This is what the range loop. Okay. So I hope you understand what the range loop is, what purpose we use range loop. Range loop work on collections, basically for collections, but recently they started giving range loop this one as well. Considering you want to have a loop from 1 to 0 to some values. So you can't do like this I equal to 1. Uh, you can't do this. You have to create a new variable for range loop. You cannot use create a variable elsewhere and then I want to use the variable here. It doesn't work out. Range loop like normal loops. You can't. You have to create the variable for loop. There is a big reason for that. Why you have to create a variable. We will discuss sometime later. Okay. Uh, There is a very big change with respect to loops from version 1.12 to 1.22 version as well. That also I will explain. What is that big change in loops? Okay. The way how loops used to work before and after got changed. I will explain that as well. Fine. This is what about the basic loops. This is what about the strings, how the strings work. with characters. Why I suggest you to use the range loop whenever you are working with strings. Okay, the reason is because of characters and stuff like that. Fine. The next concept we are going to discuss is another data type which is called arrays. So I copy. Sorry. We will discuss about what array is, how does the array work. After array, the most important concept is slice. Slice is very important concept. Slice takes I think 2 sessions. Slice cannot be finished in 1 session. Slice takes 2 sessions. Very important concept. Okay, so let's start with arrays, and you will have a lot of clarity between array and slice for sure. Fine. Coming to array, the way how you create normal variables, how you create constant. Okay, you can also create an array where ARR1 is the length of the variable is array. The way how you create normal variables, you also create array. This is an array. Arrays are have fixed lengths. The length should be known or evaluated at compile time. Array is stored in stack memory or heap memory, that depends on again Go runtime. We cannot say array is stored in stack memory or array is stored in heap memory. We can assume here array is going to be stored in stack memory because the runtime heavily use stack memory than heap memory in most of the cases. But generally it is the decision taken care by Go. Okay. So any array is initialized. There is zero values for arrays. In this example, okay, the zero value is this is the zero value 1 2 3 4 5 because the length is 5, 5 zeros are given. This is the zero value of array. Okay, so the index starts from array index starts from 0 like C language or Java or C sharp and all. So if you print the array, it prints all zeros because zeros are the this is the zero value. You want to assign values, index starts from 0, array of 0 equal to maybe 10, array 1 of 1 equal to maybe 20, array 1 of 2 comma array 1 of 3 comma array 1 of 4 equal to 30, 40, 50. I assigned values to the array. You can print the values of the array. You want to iterate through the array. You want to iterate through the array. You can iterate with a normal loop for I equal to 0, I less than length of array. You have to give less than, should not give less than or equal to, that you know the reason. because the length is 5 but the index is not 5. Index starts from 0 to 4. I plus plus. You can say print line array 1 of I. It's gonna print the values of array this way. Let's say you want to print the sum of numbers of an array. Sum equal to 0. Sum plus equal to array of I. Okay. You get the sum of numbers of array, which is 150. Okay, you can use normal loop. But generally, most of the folks they don't use normal for loop for for string array, slice, channel, and all. Rather, people use the range loop. So, how can you use range loop here? Sum equal to 0. Again, same variable. So, I didn't put colon equal to. I already declared over here. Yesterday, someone has asked why should we use the colon equal to and all. I think they might have missed the initial things. 1 minute. Hey, hi, Da. Good morning, Da. I'm in session, Da. Sure. So, I'm sorry. So, yeah, uh, here we are not this creating a new variable with the type inference. Type inference means based on the value, it infers the type of the variable. This is assigning a value directly to a variable. Okay. Here I got to use uh, for index comma value range of array 1, but it depends on I don't want the index, I just want the value. Okay. Sum plus equal to v, the value is adding to the sum. Print line sum is sum. Okay, you can use range loop to perform the operation. It's the range. Okay, let's say I create a array where you can also create an array with a shorthand declaration. Creating an array using shorthand declaration. Okay, one question I ask: what is the type of an array? What is the type of this array?
Array itself isn't it a type? I hope this is an integer array.
Yeah. So in Golang, the type of an array includes its length. That means, okay, type is this is the type. It's not, we don't call it as integer array, we call it as 5 elements of array. 5 element. This is the type. This is the type of an array. Remember that the type is not just an integer array. The whole thing is called the type of an array. So, for example, creating an array with a shorthand declaration, for example, I create an array with 3 elements, we got to pass 3 elements. So, Array 1 and array 2 are not equal because there are two different types. Array 1 and array 2 are two different types. Very important thing because a lot of things happens because of this. Array 2 is different, array 1 is different. You cannot typecast uh, arrays of different types. Cannot typecast arrays of different types. I tell you the reason. I tell you the reason. So array 1 and array 2 are two different types, even though both of them are integers. It's a shorthand declaration. You can also create an array like this with an eclipse symbol and by passing values. This is evaluated. The eclipse symbol is evaluated as integer, as length at compile time. This is done at compile time. Nothing to be done at runtime. This is done at compile time. The compiler evaluates the value. Okay. The compiler that evaluates this value. Okay. So this is evaluated as print line. You can see the type. For example, type of array 2. You can use reflector dot type of array 2. You want to print the type of array 3. You can also use for a type fmt.print f percentage %t. You can use both. Reflect or type of is a more granular function. This is a format specifier. So because it's printing the raw print, so type of array 2 is 3 of int. Type of array 4 is 4 of int because this is evaluated and then this just a shorthand, another way of shorthand declaration. So array 2 and array 3 are two different types. You cannot typecast it. You can never say that array 1 equal to array 2 if array 2 equal to array 3. Okay. So you see that the operation itself is a mismatched operation. Even the operation is telling that it's a mismatched operation. Forget about the other one. Because two different types, there are two different types. Two different types cannot be matched. Let's say that where num1 is int, where num2 is uint8. Okay, you cannot never go and then say if num1 equal to num2. Sorry, the reason is both of them are two different types. You can do it by converting to int, by casting to int. That you can do here. But here you cannot cast it like that. You cannot go and then say that you can cast it to what is that 3 int of. You cannot cast like this. Okay, that's the reason. That just explaining you this one. So the length of the array is very important. So there are two arrays, but two different arrays basically, two different arrays. Because of these things, arrays are seldom used in Golang. Arrays are not very regularly used in Golang. Still, arrays are useful. Arrays are very important data types. The length is very known to the compiler, very useful, very good scenarios are there, but still arrays are seldom used in Golang. Arrays are not very regularly used in Golang. For simple example, I create a function sum of I I use array 5 of int. I got to return the sum of numbers because there is only one variable. You don't need to give brackets. If you give bracket also there is no problem, but it the static checker is removing it. Sum equal to 0 for range of array. Sum plus equal to v. I got to return sum. Look at the simple function sum of. Cool. I go and then use call the sum of function sum of array 1. Unfortunately, I cannot call the function for array 2. The reason is the type is different. I cannot use it for sum of array 3. The type is different. So we cannot kept on writing the array functions or methods for arrays of different lengths. We cannot go for array 4 one function, array 3 one function, array 5 one function, array 6 one function and all. It's not going to work out. So generally we don't use pass arrays as input parameters. We don't use arrays as input parameters for functions. We use a different concept called slice. We will discuss about it later on, but right now that's the concept. Okay, that's the difference. Why we don't use arrays? We don't really worry. I mean, we don't really use arrays of these problems. The type of the array is always it includes its length. Arrays cannot be typecasted. If you create a function with array as an input parameter, then always the same type of array has to be passed as an argument. Okay, this is the shorthand declaration of array. This is also the shorthand declaration of array. The eclipse symbol tells that the eclipse symbol is evaluated at compile time, not by runtime, at compile time. The compiler counts the values. There is some process called SSA, I told you, right? Single static assignment. There are so many things, constants evaluation, similarly arrays evaluation, length of the array evaluation. Okay, type inference is also one of the processes. Type inference can also be done using all these things. All these things are done by your compiler. Okay, if you create a variable and then what type that variable belongs to, it's done by the compiler based on the values. Let's say I give var, sorry, I give okay equal to true. So okay is a boolean variable. Who does that? It is done by your compiler. Okay. Who does the length of this array? It is done by your compiler. What about the zero values? Who gives the zero values? The compiler. Because of the compiler, zero values are assigned. Many things are done by compilers. Okay. This is what actually. This is what about the arrays. Okay. These are what about the arrays. We will discuss more about arrays in tomorrow's session. But right now, this is what about the arrays to begin with. So what we discussed about the loops, We went inside loops. How do you break out from the loop? Okay, how do you assign multiple variables as initializers to the loop? How to go break out from the loop? Again, I'm telling you, I'm not explaining the logic of the loops. You might have already used loops a lot. I'm just explaining little things in Go language, a few things in Go language which differs from other languages, or which are how to do in Go, which are similar to other languages. We discussed about loops, and we discussed about range loop, and then the behavior of range loop, particularly on strings. Strings are nothing but, you know, a collection of bytes. Some characters in strings, okay, consists of more than one byte. So how do you use a normal loop? How does it behave? When you use a range loop, how does it behave? That is the reason for string processing. Generally, we use range loop. String manipulation, character manipulation inside a string, or string manipulation, we use range loop. I'm not saying you can't use for loop, normal loop you can use, but quite tricky it is. You need to convert it into rune array or rune slice, or there are certain things called slices. I will discuss about that. That's the reason I didn't explain right now. Tomorrow session will start with slices, not tomorrow, on Monday. Okay, these kind of things we will discuss in the upcoming sessions, right? These kind of things we discussed, and then a function, how the function can return more than one argument, more than one return type, one return value, and what is the significance of blank identifier. Make sure that blank, and also think that blank identifier is not going to uh, allocate any memory. Okay, don't think that simple. Somebody has asked me, does blank identifier allocates any memory on a stack or heap, whatever. I said that no, blank identifier doesn't allocate any memory. So it's optimized in the inside your Go. Blank identifier, whenever you use blank identifier, it's not going to use any consume any memory. It's not going to allocate any memory for the blank identifier. And then you can use range loop. Range loop return two things: index and value. Okay, and stuff like that. These are the things that generally we work with. We use range loop. These are arrays and stuff like that. We will discuss more of these things in the upcoming session.